Okay, everyone, what is it that I want to do in this video here? I want to show you guys how to derive the work energy theorem, specifically this equation here, that anytime you do work on an object that is equal to the change in kinetic energy of the object. In other words, work done is equal to an object's final kinetic energy minus an object's initial kinetic energy. So where is it that this equation comes from? How is it that we ultimately get at this form here? So you're going to start with these three equations. Okay, these three equations are given to you. Mathematical definition of work, which is equal to force times displacement. Newton's second law, force is equal to mass times acceleration. And of course, your third kinematic equation, velocity, final velocity squared is equal to initial velocity squared plus 2 times acceleration times displacement. So using these three equations, we're going to derive the work energy theorem. Okay, so let's go ahead and get started with that now. So we know that work done is equal to force times displacement. So let's start with the kinematic equation that I gave you guys on the previous page, that final velocity squared is equal to initial velocity squared plus 2 times acceleration times displacement. Now the first thing that I want to do, I want to solve this equation here for displacement. So in order to solve this equation for displacement, I need to first begin by subtracting this initial velocity, subtracting this and putting this on the other side of the equal sign. So I'm going to do that now. So final velocity squared minus initial velocity squared is equal to 2 times acceleration times displacement. Okay? So from there, we can then get displacement by itself. And that's easy. In order to do that, we need to divide by 2a. So, and whatever we do to one side of the equal sign, we have to do to the other. So, I'm going to hit write that now. Now, final velocity squared minus initial velocity squared. All of that divided by 2a is equal to displacement. Okay? So, the purpose of that, the purpose of solving for displacement is because now that I have a displacement here, and I know what displacement is equal to, I can then take that displacement and eventually plug this in here. So that's eventually what we're going to do. But first, before I substitute that in here, I also want to substitute in something else for this force. Well, with Newton's second law, I know that force is equal to mass times acceleration. Okay? So that means I can take this here and plug that in for force. And of course, I can take displacement here and I can plug that in for D here. Okay? And so I'm going to do that on the next page here. So work done is equal to force, which is mass, times acceleration, okay, multiplied by displacement. And we just said what displacement equals. Displacement is equal to final velocity squared minus initial velocity squared. All of that divided by 2a. Okay. So again, all I did here was just do a substitution. I substituted Newton's second law in here for force, and I substituted my left-hand side for displacement. Now, from there, I want you guys to notice something here. I have an acceleration at the top, and I have an acceleration at the bottom. Obviously, when I multiply those two, they cancel. So this A cancels out with that A. And so this is what I'm left with. Okay. I'm left with work is equal to mass times displacement, where I know displacement here is equal to final velocity squared minus initial velocity squared, all of that divided by 2. Okay? So let's keep going. Okay, so now the next step, what I want to do here, I want to take this 2 here, and I want to separate it out. And here's how I'm going to do that. So algebraically speaking, this here is the same thing as this. Final velocity squared divided by 2 minus initial velocity squared divided by 2. Okay? So all of that multiplied by mass is equal to work done. Okay. Now there's a few more algebra steps I have to do here. If you guys remember, dividing by 2 is the same thing as multiplying by 1/2. So I'm going to rewrite this again. So 1/2 final velocity squared minus 1/2 initial velocity squared. All of that multiplied by the mass is equal to work done. Okay. So let's keep going. Now, one more step here. You guys see this mass here? I could take this mass and I could distribute this mass. So I could just take this and distribute it. This m times that and this m times that. And when I do that, here's what I'm left with. I'm left with work done is equal to 1/2 times mass times final velocity squared minus 1/2 times mass times initial velocity squared. Okay? And that's it, guys. That's the derivation. That's eventually what we wanted, because remember what we said before, that anytime you do work on an object, you change the kinetic energy of the object. In other words, work done is equal to final kinetic energy minus initial kinetic energy. Okay? And that's it.